Ahoy hoy! Welcome to Absolute and Reciprocal for Pre-Calculus Math 11, and we're taking a look at reciprocals of quadratic functions. Basically in section 8.3 we're looking at reciprocals of linear equations. And in this section what we're going to do is we're going to take a look at reciprocals of quadratic equations, so basically parabolas. Really what it boils down to is how many asymptotes does this parabola have, which is really based on how many zeros or how many x-intercepts does the parabola have. So the steps, pretty well similar to what we saw in the last unit. We're going to graph the equation, we're going to draw vertical asymptotes, invariant points, all those same things. But really this step 4 here, this consider where the vertex moves, that's kind of an important step. So what I want to do is let's start with sketching pretty lightly the equation in the denominator, and in this case the equation in the denominator is a parabola. It's x minus 3 squared, which is shifted over 3 units, and we have a standard parabola opening up. So I'm going to just quickly draw some dots, out 1 up 1, out 2 up 4, very lightly again drawing just kind of a dash marks because we know this is just kind of a helper graph right now. So there's the equation in the denominator. Let me go in red for the rest of this. Draw the vertical asymptotes. So I have a vertical asymptote. In this case, it's sitting right on that vertex, which gives us this one asymptote idea. Again, there is still that horizontal asymptote, and a lot of times you don't really bother drawing that in, but there we go. Vertical asymptotes, invariant points, again, wherever it equals positive 1. In this case, there's 2 spots where it equals positive 1. And negative 1, I don't have any y values of negative 1. So there's my invariant points. Step 4 here, consider where the vertex moves. Well, my vertex is actually the asymptote in this case, so there's nothing kind of reciprocal going on there. And we just approach asymptotes. Now notice that the blue graph gets trapped in between various asymptotes. So here's an asymptote kind of in this left-hand side of the vertical asymptote. And above, there's our blue graph. Our answer, the reciprocal, has to be trapped in that same region. So same thing on the right-hand side, we're trapped in that region. Stating any domain and range. Domain, again, fairly straightforward, really based on asymptotes again. X can't equal 3. The range statement, I'm going to do something a little bit later, but the range here I think should be fairly straightforward. We can see that we get as close to 0 as we can for y, but we're everything above that. So let's see if you can maybe try this one. Let's do this. Hit pause for a second. See if you can at least graph the parabola where the asymptotes are and invariant points. So we're shifted to the left 2, down 1. We have a standard parabola from there. So again, I'm just going to put kind of light dots on that. In this case, when we talk about vertical asymptotes are occurring where the function passes through the x-axis. So we have 2 of them this time, 2 vertical asymptotes. Invariant points. Well, we have an invariant point. Sorry. We have an invariant point which is slightly to the left of that asymptote. There's another invariant point at y equals positive 1. So 2 invariant points at y equals positive 1. Here's an invariant point right on the vertex, it turns out. Consider where the vertex goes. Well, the vertex is actually an invariant point, so that hasn't changed. Now we approach asymptote. So we should approach the vertical asymptote and what I haven't drawn in, but the horizontal asymptote on both sides of the outside pieces of the parabola. In between, from this vertex, we approach the asymptote. So it's kind of funny that it just kind of looks like a little parabola looking thing coming off the bottom of it. Now the domain here, again, really has to do with the vertical asymptotes. I have x not equaling negative 1 and 1, 2, 3, negative 3. So there's the domain. That's fairly straightforward. I'm going to use a technique here to show you where the range is. So what I want to do is I want to pretend I mush everything up against the y-axis. And what I'm going to shade in is exactly where I get graph. So if I mush from the left, from this left-hand side, and mush everything up against the y-axis, that is where I would have graph. And for the above piece, that's where I'd have graph. So the highlighted yellow is really where our range is, and we're trying to create a range statement for that. Below, I have everything up to -1. So I have all the y values up to and including -1. And then above the x-axis, I'm starting at 0, not inclusive, and heading everything above there. So there's a range statement, and we can certainly talk about how creating a range statement is possible, certainly during class. So now we're going to get into two kind of more difficult versions of this. Still graphing the parabola, shifted over 4, down 2, or sorry, up 2. Let me put that in blue. Over 4, up 2. Standard parabola opening down. This one looks a little bit funny because it's going to be difficult to really pick off where the asymptote is. We might have to solve this one instead. Vertical asymptote looks like it falls kind of in between the hash marks, so it's not going to be a nice value that we can just pick off. We're going to actually have to do some solving here to figure this out. The invariant points, I see two invariant points above the x-axis. That's again where that y value is 1. Where y value equals -1, it's kind of off a little bit. It's not right on the hash mark because it's really the next point down, which is our invariant point. So it's a little bit close. This is where that next step, that step 4, where you consider where the vertex moves, is appropriate. We're talking about reciprocal. We're talking about reciprocal of the y values. So let's just take a look at what's the y value of that vertex. The y value of that vertex is 2. The reciprocal of 2 is 1/2. So that y value has its reciprocal at 1/2, and we approach asymptotes. Below, it's a little bit tight there, but we should have a value heading down and a value approaching the x-axis. Let me highlight again where we get range. This is going to be at 1/2. And let's create those domain and range statements again. Domain, this is the problem, right? A domain, it doesn't fall on any nice value. So what we're going to do is let's take the denominator of our reciprocal and make it equal 0, and that's going to tell us where the x-intercepts are. We have -2, basically the non-permissible values. Taking the square root, we get plus or minus 2, and adding 4. Sorry, that's plus or minus root 2. So plus or minus root 2 plus 4 is our x values, and there's 2 of them. You could evaluate that as decimals. You could leave it as a radical. Looks great. Maybe I'll leave it as a radical x, given that x can't equal plus or minus root 2 plus 4. There's our domain statement. Range statement here, a little bit strange again. We have everything, all the y values that are up to but less than 0, not quite equal to 0. Where's that bottom edge here? That bottom edge is at 1/2, and that came from the fact that we took the reciprocal of the vertex of the parabola. Where everything above that, are we equal that? You bet. The vertex does actually move. We actually do hit that point. And there's our graph. Sorry, our range. So it starts to get a little bit more complex. Certainly this last version here is going to be really kind of strange. Same kind of deal. This one has no asymptotes though. This is going to be more conceptual. Let's graph this. We're shifted left 5, down 3, and it's a standard parabola from there. Now this is kind of funny because we don't hit the x-axis. We don't have any non-permissible values. That denominator is always going to be negative. So it never actually hits 0. So how does this affect our graph? Well, we don't have any vertical asymptotes. We still have that horizontal asymptote. No invariant points because it never equals that positive 1 or negative 1. All right. What next? The vertex. Well, the vertex here is negative 3. The reciprocal of negative 3 is negative 1/3. I'm going to just try and draw a dot there. Negative 1/3. And our vertex is moving away, so we should be moving towards the asymptote. So it actually kind of looks like a little bit of a dip in the graph there. It just kind of comes in very low, peaks, or hits the peak there at negative 1/3, and then levels off again. Kind of a funny graph. You might not see it terribly often, but really it's about taking the reciprocal of all those points. Domain of x, because we don't have any asymptotes, it's all real numbers. The y value, this might be a little bit tough for me to draw in, but let me show you here. The y value, we get up to 0 and all the way down to 1/3. So it's not really that much range that we're in. So it's a y given that, where are we? We're going from negative 1/3 inclusive, because we do hit that point, all the way up to 0, but we don't actually ever equal 0 because that's an asymptote. Certainly, the different types of parabolas we can get kind of fall into these 4-ish categories. There might be a little bit of other change, but it's really about taking y values and taking the reciprocal of them. This actually ends the notes for reciprocals of quadratic functions.